Okay, hello everyone. I welcome to all in our lecture series on laser physics. In this lecture series, we are discussing these topics which are most essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. In our last two classes, we have been discussed these two topics. In this class, we are going to discuss basic components of laser. Okay, so let us start. So these things already we have been discussed. What is the stimulated absorption, spontaneous emission and stimulated emission and population inversion. Also we have been discussed. Population inversion is a necessary condition for laser action. So to achieve the population inversion, we need a metastable state in between higher level and lower level. Why it is required, that we have been discussed in our last class in detail. Okay. In this class, we are going to discuss basic components of laser. Very often this question asked for 3 to 4 mark in your exam. This much note is enough for 3 to 4 mark. Okay. The basic components for laser are resonator cavity, active material, pumping instrument. So what is the resonator cavity? In general, it is a tube having definite length and diameter. Why definite length and diameter, that we are going to discuss in our next class. So here you can see in this figure, this is a tube having length is your L, definite length and definite diameter. Okay, here I consider the helium neon laser experimental arrangement. Okay, so the tube having the definite length and diameter. Two mirrors are placed at the two ends of the tube. This is one mirror, this is another mirror. One mirror is fully silvered or reflected. This mirror is fully silver, or you can say fully reflected. That means 100% reflection capacity of this mirror. But this mirror has 90% reflecting capacity, only 10% transmission capacity. Okay, so whatever the laser light will be formed inside this tube, this mirror will be reflect 100%, this mirror will be reflect 90%, only 10% will be transmit outside of the system. Okay, the whole tube will be kept in a vacuum chamber to avoid the contaminant. Okay, and this is your resonator cavity. So here in case of helium neon laser, inside this tube helium neon gas are considered with definite proportion. What is the proportion, what is the working principle, etc., that we are going to discuss in our forthcoming class when I am going to discuss about the helium neon laser. Okay, here you can see, if we are going to consider the ruby laser system, this is a rod having the definite length. One end of the rod is reflecting, fully reflecting, and another end is your partial reflecting. And this is the rod is called as your ruby rod. That means it is a basically aluminum oxide doped with chromium rod. Okay, for the ruby laser system, this is your helium laser system, and this is your hydrogen fluoride laser system. Here you can see this is the cavity, resonator cavity, or you can say the rod. This is the fully reflecting mirror, and this is the partial reflecting mirror. Okay, okay. Active material. Active material is that material in which population inversion can be achieved, which is essential for the stimulated emission or laser action. So here active material means in that material we can get the stimulated emission or the so-called population inversion will be achieved. So here in helium neon laser, neon is the active material. How neon is the active material, at that time I will discuss. Okay, here I also written with the example, in helium neon laser, neon atoms act as active material, but in ruby laser, ruby rod having the length 4 cm is act as active material. Okay, Just now I shown you this is the ruby rod. So this rod is the active material itself. But in case of helium neon laser system, neon is the active material in which we can get the population inversion. How and why, that we are going to discuss later. Then pumping instrument. It is the instrument which provide the energy to active material from outside. So here neon atom, or you can say in case of ruby laser, ruby rod is the active material. So how we are going to provide the energy to the active material that the atoms will be activate or atoms will be moved to the higher energy level? For that we have to consider the energy from the outside. That process is called the pumping, or the instruments are used called the pumping instrument. So here same thing it has been written. It is the instrument which provide the energy to active material from outside. As the result, atom or molecule or electron will excite to higher energy level to provide the population inversion, that is N2 greater than N1. Right. Various methods are available for pumping: optical pumping, electrical pumping, and chemical pumping. Optical pumping generally you can found in your ruby laser and Nd:YAG laser, in your solid state laser. So this ruby laser system, we are using the optical pumping. That optical pumping means, here you can see a xenon flash lamp is wrapped over the ruby rod. So when the xenon flash lamp which is flashed, the light energy propagates inside the ruby rod and the ruby rod will be activated. In this case, in helium neon laser system, here you can see anode and cathode. So externally a electrical energy or battery or electrical source will be connected to this system, and electrically the active material will be activates. So same thing it has been written, electrical pumping basically we can found in helium neon and excimer lasers. Chemical pumping means we have to use those active materials automatically, they are going to uh, react with each other, and we can get the automatic, they will activate themselves. That means here this is the chemical pumping system. Hydrogen fluoride laser, in case of hydrogen fluoride laser, hydrogen will be insert inside the gas chamber. This side fluorine will be insert. So hydrogen and fluorine, they will be interact or they will react. It will be produce energy. Okay, that energy again it will be used for activation of hydrogen and fluoride. Okay, so these are the three basic methods or basic instruments we have to use to activate the active materials in different laser systems. Okay, so this is all about your basic components of laser. In our next class we are going to discuss resonance condition and threshold condition for laser oscillation. These conditions are essential conditions for laser action. See, already we have been discussed necessary condition is our population inversion. After all, these conditions should be satisfied by a laser system to provide the laser action. So these two conditions we are going to discuss in our next class. Thank you so much for watching this video. Thank you.